So today we are deriving the mean of a negative binomial distribution. We recall that this is the PMF of a negative binomial distribution. Going down, this is the mean. Mean is x times our PMF, as stated here. So we want to take this segment of our equation and expand it, the combinatorial segment of our equation. So we're going to say x into brackets r plus x minus 1 factorial out of, when we subtract this, x plus r plus x minus 1 and x, we're going to get r minus 1 factorial times x factorial. When we define the definition of x factorial is x into, the definition of x factorial is x into x minus 1 factorial. So if this is correct, it's going to be the same for r. Here we want to make r minus 1 factorial the subject, where we get r factorial out of r. So we want to substitute our summary into this section, our segment, our combinatorial segment that we're expanding. Where here, when we come down, we come and say r plus x minus 1 factorial out of this r minus 1 factorial. We're going to substitute it by r factorial out of r, as we wrote here. So our x factorial, we're going to substitute it with x into x minus 1 factorial. So we're going to find that x and x cancel. Then, as we continue, we're going to, when we carry out this division, we're going to see that the r goes up and we remain with r into r plus x minus 1 factorial out of r factorial into brackets x minus 1 factorial. And when we look at this segment in this form, we're going to see that we can take it back into a combinatorial form. Because when we subtract r plus x minus 1 minus r, we're going to get this equation. We're going to get x minus 1. So it means we can take this into this form, into a combinatorial form, r into r plus x minus 1, r x minus 1. So after this what we get here is equal to this combinatorial, to this segment of this equation. So we want to substitute it into our formula of the mean, which is here. So when we substitute it here, remember we are deriving the mean of a negative binomial. So when we reach this step, we recall that the PMF of the probability mass function is equal to 1, and this is the function. So we want to make a function similar to the PMF. Yeah, so we're going to change the variables, and when we change variables, we change limits. We're going to let y equal to x minus 1. We're going to let q equal to r plus 1. We are letting y and q be our new variables. So we're going to replace our old variables in terms of our new variables. We're going to make x the subject in this equation so that it can be easy for us to substitute into our old, into this so that we can get our new variables. So when we make x the subject, we're going to get x is equals to y plus 1. So when we make r the subject, we're going to get r is equals to q minus 1. So when we substitute into this equation, we're going to get y plus q minus 1. We're going to do the same for the lower one and make sure that we replace all our old variables with the new variable. So when we come down, we get y plus q minus 1 y, combination y. Then r, we're going to also do the same for r. We're going to make r the subject here and get q minus 1. And then we're going to do the same for x and get y plus 1. Here, we're a few steps to making our equation similar to our PMF. So we're going to expand the segment P, Q minus 1. And it's going to be P, Q, 1. And then we're going to also expand this one. And 1 minus P, Y, this is negative 1. Then 1 minus P. So when we come here, we are going to, this is what we began with. Coming down, we are trying to make sure that we are trying to make our equation similar to our PMF, because we know our PMF is equal to 1. So since r is not affected, we take it outside of that, of the equation. So now when we've changed variables, our limits have changed too. So here we were working from x from 1 to infinity. Here we are working from 0 to infinity. Here we are working from 1 to infinity, because we can't work from 0, because when we put 0 here, our whole our whole equation function is going to become 0. But if we work from 1, we are going to see that our only choice is to work from 1. And here, we're going to work from 0 to infinity. Going down, when we expand this section of our function, we are going to divide. We're going to take out our P, because it will not be affected by the limits. And we're going to take out 1 minus P also. And it's going to become R. When we take out this, it's going to become times 1 minus P. This is a negative 1, so it's pushed down. Summation, since we changed variables, to infinity. So this, when we look at this function is similar to our PMF. And so this is going to become 1. So this part times 1 gives us our mean equaling to R, 1 minus P out of P. And our mean of a negative binomial distribution has been derived. Moving on, we want to derive the variance. We're going to derive the variance we're going to derive the variance of a negative binomial distribution. So, considering we derived our formula for our mean, during this step, we're going to consider that it's correct. Yes? But we know our formula for variance is expectation of x squared minus expectation of x squared into brackets squared. And when we bring out the e, we want to expand it. We want to simplify it. We're going to, variance is also equal to this. We know mean, we know that mean is the expectation of x. So our expectation of x is equal to r into 1 minus p out of p. So we're going to look for a formula that can give us the expectation of x squared. And when we work from e, expectation of x into expectation of x minus 1, we're going to get e into x squared minus x. It's like legit wrong and it's not